Let's do some more work with Venn diagrams. So here we have an example. And again, I took this from your text, so if I know it's a little hard to see on the camera, but this is example 2 in your text in this section. So you have the Venn diagram already created. And sometimes what we'll do is we'll label the different sections of a Venn diagram just to make it easier to talk about. So you'll notice that you have one section here labeled 1. So that would be this part of A, right? Then you have another set here labeled 2. So that's this like in the middle set, that overlapping region. You have another group here. So I shouldn't say set, I should say group, labeled 3. So we're just talking about different parts of the Venn diagram. And then you have the 4th region down here, which is sort of everything that's not in one of the sets A or B, right? It's that leftover stuff that's still in the universal set, but not everywhere else. So let's answer some of these questions, again, using this Venn diagram. So I'm just going to go in order here. So the first thing it's asking us to talk about is what is the universal set? So that would be everything included, right? So I see A, B, and C. I see D. I see E. And then I also see F and G. So your universal set is everything in that rectangle. Next, I'm going to talk about set B. Now, you want to be careful here, right? So I need more colors. So set B is this whole area, right? Set B is this whole circle. This is B. So what are the elements in B here? Well, there's D and there's E. The set of elements in A, but not B. So this group right here are elements in A and B, right? So the only element in both of them is D. So I want elements that are in A, but not also in B. So for part C, the elements in A are A, B, and C, but I don't include D here, right? Because I don't want it to be in D. The set of elements in U that are not in B. So again, I want the universal set, but I don't want to include any of those elements in B. So what do I have left? I have A, B, C, F, and G. Now for E, it says the set of elements in both A and B. So we kind of already talked about this one. So if it's in both A and B, that's this overlapping region in the middle, right? Because here are all the elements in B, and then here are all the elements in A. So this piece in the middle is D, that's your overlapping region. So that would be your elements in both. Also, we're going to find F, part F, which is the set of elements in A. Okay, so remember your elements here. So A is this circle, so it's all of this for A. So it's going to be the A, the B, C, and the D that's in the middle. Okay. G, the set of elements in B, but not in A. Well, we know the set of elements in B are D and E, right? We can see that here, we can see it here. But we don't want them to be in A, and we know that D is also in A. So the only element that is in B, but not in A, is E. The set of elements in U that are, again, not in A. So I have all my elements for U, but I do not want to include the ones that are in A. So what's left over would be E, F, and G. And then finally, the set of elements in U that are not in A or B. So it's not A, not B. So they're not in either one of those sets. So I don't want any of these values. I just want the ones that are left over. So the F and the G. So just some examples here of kind of playing around with those Venn diagrams and learning how to read them. So just really figuring out where those overlapping regions are, what our different sets are, and so on. Now, we've been using this idea of not a lot, and this actually is a really important definition. So the complement of a set, we'll say set A, is symbolized like this. So it's A with this little dash there. So whatever set we're talking about, if you want the complement of it, we use this little dash. It's the set of all elements in the universal set that are not in set A. So you have the complement of A would be all elements in the universal set, but that are, again, not in A. So it's almost like this idea of not, right? So if you just think of not A, then you have the idea of the complement. So if we let U be the set of numbers, 1, 2, 3, 4, 5, 6, 7, 8, 9, and A be the set of numbers 1, 3, 4, and 7, we're going to find the complement of A. So not A, right? So the complement of A is everything else. So notice that A has 1, 3, 4, and 7. So I want all the other numbers that are left over that are not in A. So I have 2, 5, 6, 8, and 9.